Now we're going to take a look at how we can actually calculate some probabilities using a normal distribution. I have some basic calculator command information up near the top, but I'm not going to go through that right now. We'll come back to that in a moment when it relates to the question in example 2. So what we're going to be looking at here is what we'd refer to as a general normal distribution with just some value for its average and some value for its standard deviation. Now, if you go ahead and look at the formula sheet, we will now be working with this middle column on our sheet, which corresponds to Chapter 5 and the normal distribution. Remember that our formula sheet is essentially a flow chart that's going to tell us what we're supposed to do as we progress through each and every problem. So we want to understand how this flow chart is going to work specifically with this middle column and our normal distribution. So let's see how we would actually go about doing that as we look at example number 2. Okay, so let's take a look at example 2 here and see what it says. A survey indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. The lengths of time in the store are normally distributed and are represented by the random variable of x. Okay, so right away you'll see here that I have a little bit of space, and I'm going to start by progressing down my formula sheet before I even read part A. Okay, so my formula sheet says that the first thing I need to do is to identify my random variable. I need to know what my random variable is. How is it going to be defined? Then I'll determine what distribution I'm working with, and then I can go ahead and perform my checks to make sure that I've actually selected the right distribution. Notice in this normal distribution column that we have here, our checks are that either the problem should just either directly tell me that I'm working with the normal distribution, or I'll be able to, in a later section within chapter 5, I think it's section 5.2.3, I'll be able to use raw data to construct a special kind of graph that will let us know if it's safe to assume that we are working with a normal distribution. Okay, so let's see how this is going to all work in the example that we have. I'm going to start by defining my random variable x. The problem already tells us, so I'll just kind of recap. We'll say we're going to let x represent the amount of time a shopper spends in the store. We don't know what that time is going to be, but we definitely know that since it's time, it's going to be a continuous random variable. So if I wasn't sure like what side of the formula sheet I should even be on at the start of this question, hopefully that narrowed it down. I now know that I'm definitely dealing with a continuous distribution. Okay, the next thing would be to state what distribution x has, but the problem already tells me the lengths of time are normally distributed. So I'll say x has a normal distribution, and I know that because the problem says so. Now the other thing that I want on the formula sheet is to find the parameters. So in this case, that would mean that I'm looking here for a mean and a standard deviation. So I can see here that the average time a shopper spends in the store is given to me as 45 minutes, and the standard deviation for that is 12 minutes. Okay, so once I have all of that, I can finally be ready to go ahead and deal with the calculator commands. Now, on the formula sheet, you'll see that I have two different calculator commands written down here. I have a normal CDF and I have an inverse normal. And it's important to note right away that the normal CDF only ever calculates a probability, while an inverse normal, written here second, will only ever calculate a value of x, meaning a number that would occur on our horizontal number line. In this section, we'll primarily focus on using normal CDF, and in a future section, we'll go into more detail about inverse norm. But again, it's really crucial to keep in mind that there's a difference between these two commands. Normal CDF is a command that we'll use to calculate probabilities associated with our normal distribution. So let's take a look at how we would use that normal CDF command and where exactly we might find it on the calculator. Let's see what we have here. Find the probability that a shopper will be in the store for more than 39 minutes. Okay, so I'm going to start by taking some time to draw out a quick picture of my distribution. I know I have a normal distribution, so I'm going to sketch out a normal curve. I know that my average is 45 minutes, and I know that my standard deviation, although it's hard to picture, I can kind of draw it next to this picture. That'll be important in some of the later sections, and so I highly encourage you to do it now. But now let's take a look at this 39 minutes and the fact that I want to be more than 39 minutes. I can easily figure out where 39 minutes goes on the number line and at least eyeball it. Let's say it's right here. It's definitely less than 45. So, if I want to find the probability that I'm more than 39 minutes, well, that would mean that I would be interested in trying to shade above 39. Now, back with the empirical rule, this would have been a very difficult question to answer because the empirical rule didn't allow us to go anything but whole numbers of standard deviations away from our average, and 39 is certainly not 12 units less than 45. However, with this new calculator command, we can actually calculate the area of that blue space, which corresponds to that probability. First, let's write out our probability notation, as we're always required to do on probability questions. So we want the probability of x, which is the amount of time the shopper spends in the store, to be more than 39. That's what we want. Now, to find that, we're going to use a calculator command called Normalcdf. Now, the way that Normalcdf works is it requires 4 different inputs. The first and the second input are meant to communicate the left and the right side of the blue space, so where the blue space starts and where it stops. In this case, it's pretty easy to see that my blue space starts at 39, but where does it stop? Well, it doesn't really stop anywhere. It kind of continues to go on and on and on and on forever. Well, that's why up here on the box, I'll state that if the upper boundary is infinity, that is, if I keep shading over forever, and we can't actually write infinity here, then instead I'm going to use an extremely large number. The number I'm going to use is 1e99. Now, see how I write this out? This is 1e99. I'll show you how to type that into the calculator in a moment. But what this means is this is the same as actually saying 1 times 10 to the 99th power, or that's 1 followed by a whole bunch of zeros, specifically 99 zeros, which means this number is huge. That number is massive, and while it's not infinite, it's gonna really give us an accurate result. Okay, so the first 2 numbers again just gave us exactly where we were going to be starting and stopping that blue space. The next 2 numbers are going to be our mean and our standard deviation in exactly that order. And it is required that you write this down on the page so I know what it is that you're planning to type into the calculator. Now we can try to switch over to the calculator and see how exactly we type this in and get our decimal approximation. Okay, so if we switch over to the calculator here, I can click on Second and the Distributions menu. This is the same spot where I went to find something like a binomial PDF or CDF. But in here, you'll notice right at the top, I have Normal PDF and Normal CDF. Okay, immediately I want you to be aware that Normal PDF will never be used in this class. Never. Never. Not ever. Not one time. Not even half a time. Just 0 times. The moment that you are in any sort of a problem or worksheet question or anywhere and you're thinking to yourself, maybe normal PDF? No. Never normal PDF. Ever. Never, ever, 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 ever. We will only be using normal CDF and inverse normal. Let's take a look at normal CDF. You'll see right here, I open it up and it has the same basic piece of information. Lower, upper, 0, 1. So I'm going to start entering my numbers in. My lower value, where my blue space started, was 39. My upper value was 1, followed by an E and a 99. If you look above 7, you'll see that there's a comma button here, but I'm not going to click this button to get a comma. If you notice above it in blue or in yellow, you'll see these capital E's. That's what I want. So I'm going to click second and the comma button to pull in that little E. And then I can put 99. Then I'll put down my mean of 45, my standard deviation of 12, and I'm good to go. If you don't have that fancy calculator menu, you just actually have to type in this in exactly this order on your main screen, and you can use, again, that comma button right above the 7 to do it. Now, if I click Enter, I should get a decimal value, 0.6915 if I round to 4 places. So I'm going to go here, and I get 0.6915. Notice what this has told me is this is the amount of blue space that I have, and that is the probability. Okay, so let's take a look at how we would do something like part B. Find the probability that the shopper will be in the store between 24 and 54 minutes. All right, I'm going to try to do the exact same thing that I just did a moment ago. I'm going to go ahead and say, let's draw out a nice normal curve. I'm going to put 45. Standard deviation is 12. And now I know that I want to be between 24 and 54. Okay, so let's see. 24 would be somewhere like over here. 54 would be somewhere up here. And if I want to be in between them, then the space that I'm interested in shading is right here. Okay, so let's think about how we would write that in probability notation. I want the time that I spend in the store to be bigger than 24. So 24 is the lowest. The value that I get can be anywhere else in between. And then I want to be lower than 54. There we go. I know that I can set that up using a Normalcdf. I would start at 24. I would stop at 54. That's the start and stop of the blue space. And then I would type in my mean and my standard deviation. I'll go to the calculator and type this in as well. So let's see. I can do second bars, Normalcdf. I'm going to go from 24 to 54, and 45 and 12 are already in there. If I click this, 0.7333. So I get 0.7333. This is really easy. It maybe takes a little bit of getting used to be careful with your inequalities and stuff, but hopefully the idea itself makes a lot of sense. I just have to tell the calculator where this blue space starts and stops. Let's take a look at one more here. Find the probability that the shopper will be in the store for less than 12 minutes. Okay, so we're going to go ahead, same thing as always. I'm going to sketch out a little picture here. So here's my average of 45. I know I have a standard deviation right now of 12. And I know that I want to be in the store for less than 12 minutes. Okay, well that's not too difficult. Let's see, if I put 12 on the number line, it'd be somewhere like way down here. And I want to be less than 12 minutes. So I'm going to shade this direction. Okay, so let's see if we can set that up. I want the probability that x, the amount of time I spend in the store, is something that is under 12, less than 12. I know I can set that up with a Normalcdf, and I got to talk about where this blue space starts and stops. Remember, I'm reading that from left to right. So what I can see here is that it's clearly going to stop at the value of 12. But if I'm coming at it this way, like where does it start? What's the low side? And that's kind of weird. There really isn't a low side because this thing can be shaded down forever towards the left. So instead of using something like negative infinity, we'll go ahead and use negative 1 E99. That way it can stand for a very large but negative number. Well, now I'll go ahead and just say that I stop at 12, put in my mean and my standard deviation, and I'm good to go. If I go ahead and type this into the calculator, you just have to make sure that you're careful about one thing. Remember that whenever you want to insert a negative here, you're going to get an error if you click this minus sign. So don't do minus 1 E99. If you go ahead and paste and try to enter that, it's going to throw an error. Instead, over this symbol, you want to click your negative sign. It's going to make it a little bit smaller up there. That's what you're looking for. So notice now I have everything in place. And if I hit enter, I get my value of 0.00297. That 7 needs to round up, though. So the 7 rounds into the 9, but then the 9 kind of rounds up. You can kind of almost imagine that the 7 rounds into the 29. So if 29 goes up by 1, you just get 30. So this should be 0.0030. So I should end up with 0.0030. So notice here on every single one of these questions, I'm including 3 important things: the probability notation, what I'm typing into the calculator, and the final answer. The picture is technically optional. I'm never going to grade you on your picture, but the picture is the best way to help organize your thought process. And so as always, I'll encourage you to include it.